Hello. So today we're going to be doing a little more trigonometry. And you'll notice I have a split screen here because we are going to be using our Desmos calculator. I've decided to show you how to use Desmos because you're going to be using it on your test that you're going to take in May. And I want you to get really comfortable with it. And it's also just much easier to use than your Inspire calculators. So we're going to go to desmos.com. And then you're going to, when this page pops up, you're going to hit scientific. So I'm going to click on scientific, and it's going to bring up this calculator. And if you'll notice, there is, and I can't like draw online, but you can see my pointer. There's sine, cosine, and tangent. Now, sine, cosine, and tangent have the same values when you actually assign them to a number. So a measurement of an angle, so to speak. So here, typically we would say this is angle M. And if I asked you for the sine of angle M, okay, I see the problem with this right now already. My eraser, I can't see it. Can't see it. If I asked you for the sine of M, then you would say, oh, well, that's x over 19, because that's our opposite over our hypotenuse. Well, because every triangle that I draw that has 29 degrees as our M is going to have 61 degrees up here. They're all similar triangles. So those ratios between the opposite side and the hypotenuse for that 29 degree angle are all the same. So that gives me a value. And I guess that's a 28 degree angle. Guys, me and these numbers on these worksheets, right? So now what I want to show you over here on Desmos is that that sine of 28 actually has a value attached to it. So if I hit sine 28 degrees and hit enter, this is the value of that, which is pretty awesome that there's actually like a decimal that gives us what that ratio measure actually is. Okay, so now how do we use this to find variables? Well, like I said, we know that sine of M equals our opposite side over the length of our hypotenuse, right? Well, instead of having M here, we're going to change this to a number, 28. So sine of 28 is x over 19. So now I just have numbers there. So I'm going to multiply both sides by 19. And I get 19 sine of 28 equals x. So now what I'm going to do over here in my calculator is I'm going to put 19 sine 28, close my parentheses and hit enter. And there is my measurement for x. So x equals 8.919. All of that's going to round up. So 8.92. 8.92 is the measure of x. Don't worry, we're going to see all of these. The hardest part is figuring out what they've given us. So I want you guys to still be in the habit of marking your angle with one color and your opposite side with another. So in this one, they've given us the opposite side and the adjacent side, right? So this 32 is our adjacent side, And this down here is our hypotenuse. So if we have our opposite and our adjacent side, that should tell us that we're going to use tangent. So we're going to say that the tangent, I don't know why these random lines show up. I still haven't figured it out. Tangent 41 equals x over 32, because our opposite side over our adjacent side. So now I'm going to multiply both sides by 32. So 32 tangent 41 equals x. And all I have to do is go to my calculator. 32 tangent 41. And so x is 27.8172. 28.8172. Okay, let's go on to number 6 here. So here's our angle, and here's our opposite side. So they have given us our adjacent side and our hypotenuse, which tells me I'm going to use cosine. So cosine 21 equals x over 26. 26 times the cosine of 21 equals x. Now notice that when I multiply, that these numbers are going out in front of our trig function. So when I multiply by 32, I put the 32 out front. When I multiplied here, I put that 19 out front. If you put it after, if you put 26 times 21 after the cosine, it will, your calculator is going to get confused. So it's easier to help with the calculator to put it out front. So we're going to have 26 cosine 21. And we get that x is 24.2731. So we're doing all of these to 4 decimal places. Okay, on to our next one. We've got this 55 degrees. There's our opposite side and our adjacent side. So our adjacent leg. So we're going to use tangent, opposite and adjacent. So I've got tangent 55 equals x over 8. 8 tangent 55 equals x. 8 tangent 55 over on my calculator. And I get 11.4252. There's our side. Hope this is making a little bit of sense to you all. So with 8, we've got 33 and 15. So we have our opposite side and our hypotenuse, which tells me sine. So this is sine of 33 equals 15 over x. Now, up to this point, we've had our x on top. So now we have to kind of do a little bit more switching of our variables. So I'm going to multiply both sides by x. So I get x sine of 33 equals 15. But that doesn't get my x by itself. So I've got to divide both sides by sine of 33. Now, again, guys, like if I put sine 33 in, it's just a number. It's always just a number. This, with these letters involved in it, it's just representing a number, okay? So just like pi, when I say pi, you think 3.14. That's all sine 33 is. It means 0.544, whatever. But we just treat it like a number. So now we have x equals 15 divided by the sine of 33. So I'm going to do 15 divided by sine 33. Don't you love how Desmos just puts that right in like a fraction? And so I get that x, I'm going to write this in different colors so you guys can see it. X is 27.5 27.5412. Now, you have, the reason that you have all of that blank paper is because I know how tiny these boxes are, so you can write these out to the side if you need to. So we have, there's our angle and there's our opposite side, which means we have the adjacent side and the hypotenuse, which is going to give us cosine. So cosine 43 equals 36 over x. And you can just assume that you can switch your x and your cosine. So you don't have to go through all of this algebra. You can just switch it. So x is going to be 36 divided by cosine 43. So we do 36 divided by cosine 43, and we get that x is 49.2238 when we round them. So make sure that you're rounding correctly. We had that problem when you guys were working in class. Okay, question 10. Question 10. Okay, we're given 72. And there's our opposite side. And then our hypotenuse is over here. So that means that we have the adjacent and the opposite. So that's going to give us tangent. So tangent 72 equals opposite over adjacent. Notice that x showed up in the denominator again. So that means we're going to have x equals 25 over tangent 72. So we come over here, 25 divided by tangent 72, and we get that x is 8.12299. So we're going to say 1, 2, 3. That's how that's going to round. Okay, this is our last of our easy ones. We're given 64. There's our opposite side. So we have the adjacent and the hypotenuse. So that's going to be cosine. Cosine 64 equals x over 11. And now we have that 11 back in the denominator. So 11 cosine 64 equals x. Make sure you put it in Desmos correctly. 11 cosine 64. And we get that 4.8221 is our x. Okay, 12 and 13 are word problems, and I thought it would be good for us to go ahead and practice how to do these. So Jake leaned a 12-foot ladder against his house. So if we say, here's Jake's house, here's the ground. So I'm even going to label these for you. House, ground, and then here's his ladder. Make it look like a ladder. And his ladder is 12 feet long. If the angle formed by the ladder and the ground, so here's our angle formed by the ladder and the ground, is 68 degrees. How far from the base of the house did he place the ladder? So how far is the ladder from the house? So that's our x, our unknown. Now, I changed that 68 so that we could make our opposite side our house, right? So that means that they gave us the hypotenuse, and they're looking for our adjacent side. So we are doing cosine. So cosine 68 is going to equal our adjacent over our hypotenuse. So we have 12 cosine 68 equals x. I'm just going to put it in my calculator. And we get that x is 4.495 3 when we round it. So he put his ladder about 4.5 feet from the house. And you would make this feet. Okay. Not too bad, right? Always, always, always draw a picture. So 13 says a ramp is used to load suitcases on an airplane. So here's our ramp. We've got our cargo door. I'm going to put that at the top here. There's our door. There's the ground. And it's 7 feet off the ground. And the angle formed by the end of the ramp and the ground, here's our ground. And this angle, I'm going to make it purple because my opposite side is purple, is 25 degrees. How long is the ramp? So we don't know how long our ramp is. If you guys need ramp. And then I drew the door. So there you go. So this one we have our opposite. And we're looking for the hypotenuse. So that is sine. So we have sine 25 equals the opposite over the hypotenuse. Remember, we can just switch our sine and our x. So x equals 7 divided by sine 25. 7 divided by sine 25 gives us that x is 16.564. So that ramp is about 16.5 feet long. Okay, now I am going to put Desmos away because we're going to talk about those special right triangles really fast. This is another reason you have all that extra room. We're going to talk about finding the sine, cosine, and tangent of our 45, 45, 90, and our 30, 60, 90 triangles. So, if you'll recall, I'm going to draw them here. Here is a 30, 60, 90 right triangle. And we remember that our side opposite 30 is x, our side opposite 60 is x root 3, and our side opposite 90 is 2x. So if I asked you for the sine, cosine, and tangent of 30 degrees, you could use our special right triangle to find what those are. No matter how long our edges are, these values are going to stay the same. So sine of 30 is going to be x over 2x, which reduces to 1/2 because our x's cancel. Cosine of 30 is going to be x root 3 over 2x. And again, those x's cancel, so that gives us root 3 over 2. And then tangent is x over x root 3. Now this becomes 1 over square root of 3. But remember, we have to multiply by root 3 over root 3. So we get square root of 3 over 3. So these values here are consistent no matter how big or small that 30, 60, 90 triangle is. And also, it works the same way for the 60-degree angle. So sine of 60, cosine of 60, tangent of 60. Sine of 60 is x root 3 over 2, x, which is going to just be square root 3 over 2. Cosine of 60 is x over 2x, which is 1/2. And tangent of 60 is actually a little bit easier because it's x root 3 over x, which is just the square root of 3. So again, you'll notice that all of these, the cofunctions, are opposite for those angles, those complementary angles. So now, with a 45, 45, 90 triangle, we're only really worried about sine, cosine, and tangent of 45 because both of the angles in this triangle are 45. So we have x, x, and x root 2. So sine of 45 is opposite over hypotenuse, which is 1 over square root of 2. which again, we have to multiply that by root 2 over root 2, and we get square root of 2 over 2. Cosine, guys, x over x root 2, what do you notice? Sine and cosine are the exact same because this is an isosceles triangle. So the opposite and the adjacent are the same. So this one is also square root of 2 over 2. And then tangent throws us a lovely little curveball because it's just x over x, which is just 1. So tangent of 45 is just 1. So these are ones that you eventually will have to have kind of memorized and know the exact values for. So I wanted to throw them out there, and that's why we talk about these special right triangles, is because we are able to find the exact value of sine, cosine, and tangent. As where when we were doing sine, cosine of all of these other angles, I mean, we don't have an exact value. We've only got that decimal approximation. So as always, we'll talk a little bit more in class, and if you need extra help, you can always ask for it.